Very warm welcome to all of you. Today we'll be learning about your second order differential equations, which are, in a sense, differential equations with your order 2. That is, the highest derivative is second order. So, what is the standard equation of the second order differential equation? We will learn. The standard equation is you have d square y by dt squared plus a dy dt plus by is equal to 0. This is your standard form of the second order differential equation, and we solve the differential equation from this very fundamental base equation. How do we solve it is the process in itself. What are the technicalities involved? We'll explore that. So in this video we will learn how to solve. We'll also learn the technicalities of second order differential equation problems, like Euler-Cauchy equations. You have your UC-SAT method for non-homogeneous, and so the like. So we'll explore a lot of things today in this video. So to start with, how to solve. Say you have been given the differential standard equation y double dash plus ay dash plus by is equal to 0, wherein y double dash corresponds to d square y dt squared, y dash corresponds to your dy dt, and say your y is just a normal y, right? You can obviously have your y in terms of x. So if you take that in terms of x, you will get, let's say, y double dash will then be replaced by d sorry y double dash will then be replaced by d squared y dx squared, y dash replaced by dy dx, and y remains y in itself, right? So we'll not go into that, but we'll go into the process as I told, how to solve. So if the equation is y double dash plus ay dash plus by is equal to 0, we first form something called an auxiliary equation. Auxiliary equation. Now, what is this auxiliary equation and how does it help us? This auxiliary equation that we get right over here is the equation from which we'll be finding out the solution of the given differential equation, for which we have to find the answer, the solution. Each and every differential equation has a solution of its own. There is something called the uniqueness of an existence theorem, which we'll come to later, and we'll also know about Wronskian and linear dependence and independence and all the like. But for the time being, we will learn about this auxiliary equation. So the auxiliary equation for this particular function would be, assuming y is in respect of x, it would be m square say plus am plus b is equal to 0. So you see, you're taking the coefficients, this relates to this, b relates to this, and since there's a 1 here and here's implied 1, that relates to that. So basically this is just about a correlation. In essence, now you have to find out the two values of m. So m gives you the value minus a plus minus root under of your a square minus 4b times c whole divided by 2. This is your a. Now in practical cases, obviously you will have the values, the coefficients a and b given to you. So this value of m will be strictly numeric, strictly something, let's say m1, and let's say, sorry, this looks pathetic. Let's say you have the two values of m, you find out as m1, and you find out the second value as m2. So you have these two values to yourself, but how do we put it to use? That is a question in itself. Now that we know that m is equal to m1 comma m2, we can find out the solution of the differential equation. Now to find out the solution of the differential equation, it is a very easy task, but it is divided into three parts. How those three parts are there, we'll come to know about it. Let's say in the previous page, as we discussed, that this is the providers the value of m, right? So we will find out that m can have three types of your values. One, it can be real and distinct. Second, it can be a case of equal roots, that is your a square is equal to 4b. I must make a correction over here. It will just be a simple b, because yes, you have the value of a actually in terms of the quadratic equation is 1. So there's that, right? Equal roots you have, and you have the case of complex roots, wherein your roots are in the form of m, say is equal to alpha plus minus beta I. So you have three types of equation. So case 1, that is roots are real and distinct. In this case, your solution y will be a e to the power m1x plus b e to the power m2x, where your a and b are both arbitrary constants, right? Arbitrary constants, you can assume the values as per the required given IVP question, initial value problem question, right? Uh, this is because uh, the the fundamental general solution of any second order differential equation lies with y is equal to c1 y1 plus c2 y2. This is your general solution of any second order differential equation. But we'll now, for this particular time, we'll learn the three cases first. So case 1 we have already studied. Case 1 we have studied roots are real and distinct. So the second case, which is your case 2, roots are going to be equal. So what in this case, you have m1 equal to m2 equal to say value alpha, right? So you have the same value alpha. Then your solution becomes y is equal to a plus b times x whole multiplied by e to the power alpha x, right? So this is your solution in the case that roots turn out to be equal. So here also it complies. If we expand, we find that it is a e to the power alpha x and b x e to the power alpha x. So here also it complies with general solution. If we consider a as say c1, e to the power alpha x as y1, b says c2 and x e to the power alpha x as y2, it also complies with the general solution. So we are done with two cases now, and we have the last case, that is the case of complex roots left. So the final case, which is case number 3, that of complex roots. So let's say we have the value of m in the form of alpha plus minus beta I. Your general solution for the differential equation in that particular case would be y equals e to the power alpha x times a cos beta x plus b sin beta x. Mind you that here again a and b are two constants and they bear no relation absolutely no relation with either of the last two cases. A and B, although I've denoted A and B in all the equations, they actually are different constants depending upon the value obtained from the your, it is called IVP, which means initial value problem. So it must be determined, the value of constant should be determined. But this is the general solution. If you expand it, you'll also find that it complies with the general solution of the second order differential equation. So this is your way how you solve second order differential equations, and we will discover about the basis of solutions and linear independence of solutions in the upcoming videos. So just a quick revision of what we have gone through or studied. Second order differential equation. What is second order differential equation? As I have defined, it is an equation containing second order uh, differential in its equation, and it can be either of two types. It can be homogeneous, it can be non-homogeneous. We'll come to that non-homogeneous part. So we have studied about this, the general form. We have studied how to find out the auxiliary equation. We have studied that if we know the value of m, the two quadratic values of m we will get, because we are forming a quadratic equation. So we get two values, m1 and m2, let them be. So we can have three types of solutions. We can have a case of real and distinct roots of m. We can have a case of equal roots of m, and we can also have a peculiar case of complex roots of m. Uh, After that, we have come to discuss the three cases. How do we solve? Which are: case number one, roots are real and distinct. Case number two gives us roots are equal, which gives the equation a plus bx e to the alpha x. And case number three, which gives us y is equal to e to the power alpha x times a cos beta x plus b sin beta x, where a and b are, again I tell you, constants, for arbitrary constants, and alpha relates to this alpha and beta relates to this beta, right? So we will, that is pretty much it about homogeneous equations. In the upcoming video, homogeneous we have learned. In the upcoming video, we will learn about your non-homogeneous differential equation. We will learn about non-homogeneous differential equations. We will learn about the basis of solutions, and we will learn about linear independence or dependence, whatever may be. So we'll learn about all the three in the upcoming videos. So if you have any doubts, you can obviously put them in the comment box. I'll try my best to respond. And till then, happy learning. You can always pause, you can always rewind, you can always play it back at your own convenience. My videos are there for you to learn. So make full of use of your time, and as I say always, happy learning. Bye.